Assalamualaikum and hi. My name is Hakim bin Razlan and my matric number is 200354.
Assalamualaikum. My name is Muhammad Zahiri bin Zaini Hisham and my matric number is 200929.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Adib bin Muhammad Hisham. My matric number is 200451.
Okay, I will present about the introduction. In the engineering field, there will be a lot of problems that need to be solved by making the most accurate calculation for the problems. Nowadays, many of the engineering problems are hard to be solved due to the complexity of the equation. So it is very important for engineer to calculate it precisely so that no error or miscalculated in the calculation that could bring harm and disaster to the system. Therefore, we have MATLAB to help us in this field. MATLAB is one of a programming software that has been created to run a programming language with precise calculation, and many engineers has been using this software to run complicated calculation without any error. As for our project background, we chose the problem from engineering mathematics, which is on how to calculate the volume of funnel and to determine the flow rate of water through the funnel. The inside of funnel of height 10 cm has a circular cross section as shown as a figure of the figure. At the height of H, the radius of the funnel is given by R equal to 1/20 times 3 plus H power of 2, where the range of H is from 0 to 10. The volume of funnel is required to find the volume of water possible to fill in the funnel. Then the volume of funnel and then the flow rate Q is obtained by multiplying the water speed by the width and height of the cross-sectional area of the water that flow through the funnel. The purpose to find the flow rate is to find how much water flow through the funnel in a certain time. The formula of flow rate is Q equal to V times W times H and time centimeter cube over S. Yes, the expectation of this problem is whether it is true that the radius and height of the funnel will affect the total of volume of funnel, and the other expectation is to whether it is true that the height of funnel will affect the flow rate of water through the funnel. Next.
Okay, thank you, Zul. So I will continue to the program development. So this is the script file of the command that need to be used in the MATLAB to make the 3D graph and 2D graph. So first, here is the height. We need to calculate the maximum height, which is here. We need to the user to enter the maximum height of the funnel, which is 10 cm. And here is when the answer at the comma middle when the user insert the 10 cm the height, and it will appear the estimated maximum volume of water is 173.5 cm the power of 3. So next we go to the 3D graph. This is the 3D graph command. First we need to put the height range, which is from 0 to 10. And after that we need to put the radius, the equation of the radius that being given, which is 1/20 times 3 plus h power of 2. And lastly, for the z axis, we need to insert the v equation, which is we get from the radius equation. Radius equation square and times with the pi and integrate it. So here is the command that being used to make the 3D plot, which is plot 3 HRV and R. This is for x-axis, this is for y-axis and z-axis. So after that, this is the command for the label. For the x label is height, for the y label is radius, for the z label is volume. So this is our title for the 3D graph, which is estimated volume of water in funnel, and the legend is estimated volume of water in funnel also. So next we go to the 2D graph, which is the water flow rate. Which is, the equation for water flow rate is Q equal to velocity times width times height. So the velocity and the width, we put it as a constant, which is the velocity we put it as 10, and the width of the funnel is the 5 cm. So when we enter we insert the answer, we'll get this on the command window, 10 and 5. So this is the command for the 2D plot, which is this is for plot x-axis, y-axis, and the classification. So after that, we need to label the x-axis and y-axis, which is x-axis is height and the y-axis is water flow rate. And the title is water flow rate cm power of 3 versus height is cm. So next we go to the result. So here we have four pictures here. This picture is for the 3D view, and this picture is for the side view from the 3D view, side view from height, and this is side view from radius. So at the maximum height, which is 10, we get the radius is 5.15 and the maximum volume of water is 173.4945. So here we can see that as the height increase, we also get the volume of the water in the funnel will also be increased. And here we can see that as the radius will increase to 5.15, the volume will also increase to 173.49. So this is the 2D graph, which is the water flow rate. We also can see that when the height is increased, the water flow rate will also increase, and at the maximum height at 10, the water flow rate will become 500 cm power of 3. So I will pass to Lokman for the discussion.
Okay, thank you, Adib. I will continue with the discussion and conclusion. Okay, for the discussion, from the 3D graph obtained, we can see that as the height and radius will increase, the volume will also increase. When the height of funnel is equal to 10 cm, the maximum value of water is 173.4945 cm3 and radius is 5.15 cm. We also can see that the estimated value of maximum volume of water 173.5 cm3 are almost the same with the graph which is 173.4945 cm3. Okay, next, from the 2D graph, you can see that the height is proportional to flow rate of water, as when the height increase, the water flow rate will also increase. Next, velocity V and width W in this graph is act as constant and it is not affected result of water flow rate, which is Q. And at the maximum height of 10 centimeter, the water flow rate is also maximum, which is 500 centimeter cube uh, per second. Okay, next, last but not least, I will explain about the conclusion. Okay, MATLAB software is a useful tool that can be used to solve many engineering problems. In this project, we use MATLAB to create a program that can be used to calculate the volume of the funnel, where the height is between 10 centimeter to between 0 centimeter to 10 centimeter, and the radius depends on the height. Another use of this program is to find the flow rate of the water through the funnel. Overall, we are able to develop our knowledge in MATLAB by using various commands to solve an engineering problem, such as using 2D and 3D plot command. So that's all from us. Thank you.
Thank you.